Algebra 2, we're looking at April 7th, Unit 3, Lessons 1, 2, 3, and 4. So go here we are, YouTube lesson. We'll be doing these lessons here. I know we did average rate of change, a lot of linear. Unit 3 is all about lines, so things like mx plus b. We got to find slope, the rate of change, and this is also very useful formula for finding the equation of lines. All right, that's not all of it, but that was a lot of it. All right, so this first one, we've got a function, absolute value, minus 2. Find the average rate of change from -5 to 7. So there's the inputs. I got to get the outputs. I'm going to take -5, plug it into the function. Get the absolute value of -1, which is going to turn into 1. Take away 2, I'm getting an output of -1. F of 7. 7 plus 4, that's 11. Absolute value of 11 is 11. Take away 2, 11 take away 2 gives me 9. So there's my outputs. So how do I find the change in outputs? You can put change in y if you like, or the change in x. So 7 take away -5. And when we put 7 in, we got 9. When we put the -5 in, we got -1. So I'm ended up with a positive 10 on top, positive 12 on the bottom. That reduces to 5, 6, which is choice 3. All right, a line is perpendicular to this line. Now, this is something I learned last year in geometry. Perpendicular, their slopes are negative reciprocals. Slopes are negative reciprocals. Well, it's perpendicular to this line. There's the slope. So what's the perpendicular slope? It would be 3 on top, 1 on the bottom, but negative reciprocal. So there's my slope, -3. Okay, and it goes through this point. Now remember I said this is useful. That's what I want. I think that's all we need. Wait. No, we got to keep going here. Y minus y1 equals slope. I just found the slope, -3, x minus x1. I'm going through this point. There's my y. Y minus 10, -3, x minus -2 is going to turn to +2. So here's the line. I'm going to solve for y. So I'm going to distribute and add 10. So -3x plus 4. There's my line. All right. What's the y-intercept? Right there. Slope, y-intercept, 4. All right. Distance a person drives at a constant speed varies directly with the amount of time they have been driving. A particular person drives 107 miles in 2 hours. How far will they drive in 1¼ hours? Okay. A couple ways of doing this. Some of you might just say, okay, 107 miles in 2 hours. You might figure out their speed. How far? You know, I think they're going like 53.5 miles per hour. That's how fast this car is going. Or what I like to do is just set up a proportion. Okay, varies directly means you can set up a proportion. So in 1 point, I'm going to change that to 1.25 hours. I don't like mixed numbers. 1.25 hours. How far did they go? So we're going to cross multiply, get 2x. I finally need my calculator here. 107 times 1.25 gives me 133.75. Divide that by 2, 66 something, 0.875, something close to that, about 67 miles. Okay. All right, this is an easy one. Number 4, we got a line, which is the right equation. Well, it's definitely going down, so you should say right away the slope is negative. And if you know that, you can eliminate 2 of these choices over here. That's a positive slope, that can't be it. That's a positive slope, that can't be it. So we're 50-50 shot right now. Okay. What else do we know? I don't know exactly what that number is, but it's definitely a positive. It's positive. It's a positive y-intercept. So which one of these is a positive y-intercept? Well, right there. There's a negative y-intercept. So this has to be the only one that would possibly fit this line. got to be going downhill and have a positive y-intercept. All right, now we move to a little tougher one. Find the equation of the line that goes through these 2 points. Okay, so I'm going to first get the slope. Change in y, change in x. My y's, 25 and 15. My x's are 20. Take away -5. So I'm going to get 10 on top, 25 on the bottom. I'm going to reduce that to 2/5. I like fractions, so I'm going to leave it 2/5. All right, come up with the equation of this line. So again, I'm going to use the y minus y1 equals slope x minus x1. Got the slope. You could pick either one of these points. I think I'll pick the 20. I like the positive number, so I'm going to use that one. Put 25 there. 20 here. Distribute. Now, you know what? Technically, you're done. You could stop here. It says find the equation of this line. There it is, but I'm going to put it in the form you're more familiar with. If this was multiple choice, they'd probably do this. 2/5 times that. Use your calculator if you need to, but I know 5 goes in there 4 times. I'm going to get -8. All right, and then add the 25. So y equals 2/5 x plus 17. So if I was putting in my calculator to check, and you could put this in your calculator and go to the table and see if you hit those 2 points, but there's the equation on the line. All right, the minute hand of a clock clearly turns 360 degrees in an hour, right? The clock, everybody uses digital clocks, but it goes around 360 degrees in an hour. How many minutes will it take for that hand to turn 155 degrees? Here's another direct variation. So we know that 1 hour, I'll put hours down here, it goes 360 degrees. Well, if you're going 155 degrees, what's your time? Okay. How many minutes? See, I should change this. They're asking about minutes. So if I do this, I'll get hours. I want to change this to minutes. So I think everybody knows that 1 hour is 60 minutes. Okay, 60 minutes. So now, 155 times 60 gives me 9,300. So 360x equals 9,300 divided by 360. All right. Divide by 360. I'm getting 25.83 repeating. Nearest minute. So 25.83 repeating, so that's approximately 26 minutes. Now if you think about this a little bit more, what's 155? That's you did some trig, so if I started here, 155 degrees will put you over here in the second quadrant. So in terms of, I didn't quite go halfway. If I went halfway, that'd be 30 minutes. I went almost halfway, so 26 minutes. That kind of makes sense. Okay. After a recent Arlington High School basketball game, traffic was exiting the parking lot, leaving the parking lot at 28 cars per minute. There's my rate of change. When you ever see the word per, that's how fast you're changing. We started with 922 cars. So basically they gave me the equation. I'm going to come over here. Determine the formula. See, mx plus b. I mean, they gave me the rate of change is -28. And they said, hey, we're starting with 922 cars. Now, I should use their letters. M minutes. So if I change the letters, this would be M. And this is the number of cars. I kind of like this equation better, but if you follow the directions, that's how you would change it. I'd take either one. So now I come over here. How many cars are in the lot after 10 minutes? I plug 10 into that. Number of cars after 10 minutes. Well, 280 left the parking lot. Gotta get my calculator. -280. Try that again. -280 plus. Start with 922, so there are now 642 cars in the parking lot. All right, really important, average rate of change. So change in the function over the change in the inputs, there's the inputs. Let's put the, I'm going to do 2, take away -3, and go the other way. Now I got to figure out, well, if you plug 2 in, what do you get? I think I can do this in my head. 8, take away 1, 7. Plug -3 in there, you get -12, take away 1, -12, that'd be -13. So I plug that in. I get 20 on top, and I get 5 on the bottom, so I get a rate of change of 4. You should not be shocked by this at all. In fact, the smart student would say, hey, I knew that ahead of time. There's the rate of change, because this is linear. Linear has a constant rate of change, linear. So it had to be 4. I just confirmed it. This is not linear, so don't look at this and just go, hey, the answer's 2 or the answer's 3. It's not there in front of you. You have to really do the calculation. I think this time I'll do a little more work. I'm going to plug 4 in. What do I get? 16 times 2, 32, plus 3, 35. Plug 1 in. So I get 2 plus 3. I get 5. There's my outputs, there's my inputs. Change in outputs, change in inputs. So 4 take away 1 I'm going to do. And when I plug 4 in, I got 35. And then I put 5. So 30 over 3. The rate of change is 10. See, it's not like obvious because this is going to change. It's a parabola. It's not going to be a constant rate of change. If I gave you different numbers, you'd get a different output here, different answer. All right, number 9. The slope of a 9 is 0.3. Positive, it's going up. What's the y coordinate? And they gave me 1 point, and they also want me to find out this other point. What's the y coordinate? When the x coordinate, oh no, I gotta find this. I'm not looking for the y-intercept. All right, so I think I'm gonna use this, much more useful than mx plus b. Call this point slope. So I got the slope, 0.3, and I got a point right there. X minus 3.5, and over here, y minus -5 is gonna turn into +5. Going to solve y plus 5 equals 0.3x. What's 0.3 times that? No idea. 3.5 times 0.3. 1.05 minus 1.05. I'm going to add, so take away 5. So here's my equation. 0.3x minus 6.05. So when the input is 10, what's the output? Yeah. Could do that. That turns into 3. 3 take away 6.05. Something's wrong. Because I'm getting a negative answer. That can't be right. So I made a mistake somewhere. Oh, I hate this. All right. 3.5 goes there. Turns into 5. Multiply. That was wrong. That was wrong. 3.5 times 0.3. 1.05 stays negative. Subtract 5. You get that. Yeah, that was great. Okay. And of course my eraser is terrible. Found it though. Everybody's laughing at me, I'm sure. There's x. And there's y. Good thing I do pencil. Try it again. 0.3x plus, that'll be 1.5. Y minus 3.5, add 3.5 to both sides. 0.3x plus 5. I feel much better now. See, so the y-intercept is 5. Now I'm looking for this value. 0.3 times 10 plus 5. That's 3 plus 5. gives me 3 plus 5 gives me 8. So, I mean, I knew this was positive. I was definitely going up. So it couldn't have been that answer I got before. So y equals 8. All right. Okay, so what's your job now? Independent work. What did we say this was? The 7th? 4-7? You got 4 multiple choice questions. This one's just like number 5 that I did. There's the minute hand again, just like the one I did. Traffic, entering the parking lot, not leaving. Rate of change. Don't make the same mistake I just did here. Very similar. So don't forget, show me some work on the 5, 6, 7, 8, 9. Make sure you're showing work. All right. Everybody stay safe.